Let's look at triangle, area of a triangle, and collinearity of 3 points in 3 dimensions. So again, we would require 3 points to form a triangle. So let's say A1, B1, C1, right? Similarly, second point would be A2, B2, C2. And similarly, another point A3, B3, C3. And since they are all values are same, so they are one on top of the other. So let's move them around. Okay. Now let's join them. Join these points to form the triangle. So segment A, B, segment B, C, and segment C, A. So this is the triangle. Now what we want to do is figure out the area that this triangle occupies. Okay, so let's convert them into vectors, right? So how would you define? So we just specify vector and we provide 2 points to this. So using 2 points, we define a vector. We already have A, B. Now let's not display AB, right? The segments, line segments. I could have avoided creating these segments anyhow. Okay, similarly, vector B, C and vector A, C, right? The advantage of defining it as a vector is then we can do vector calculations. Now, to figure out the area of a triangle, what do? 1 by 2 times the cross product of any of the two vectors, right? So any of the two vectors means we could take u. Now we can't just say u, we have to say cross product of u, v, right? Similarly, now it doesn't matter which two vectors you use, right? You can choose any one of them. So let's take it to, okay, cross product of v, w, right? Similarly, 1 by 2 times the cross product of w, v. See, the only difference is the direction. That is because we did w cross v. If we do v cross w, so the point is this positive or negative doesn't matter to us. So what do? We take the magnitude of A or magnitude of B or magnitude of C. In all the three cases, it comes to 9.49. So the negative sign disappears. So 9.49 square units is the area of the triangle. Now let's specify some values of A1, B1, C1, A2, B2, C2, A3, B3, C3, and A4, B4, C4, for which we have calculated the answer. So to figure out whether what we have set up is correct or not. So one set of values that I have is 1, 0, 0. Right? So 1, 0, 0, and then 0, 2, 0. So this is also 0. And similarly, 0, 0, 3. Oh, there is no A4 before C4. I just blindly mentioned it. And this is 0 because we require only 3 points. 0, 0, and 3. Okay, so here if you notice, the triangle is like this, and the area is the magnitude of this from origin, magnitude of this vector. Actually here two vectors are being displayed because I have asked it to. Two of them are positive, one of them is negative. That is why one of them is going below. So let's ask it to display only one of them. So this is the uh, vector which represents the area of this triangle. Okay, so what is the area? Area is coming 3.5. What I had calculated is 7 by 2. So which means it is correct. Now, what happens if the points are such that they don't form a triangle? When will they not form a triangle? When they are on the same line. All the 3 points are on the same line. What we call as collinearity. That means they are on the same line. So how will I know that these 3 points are on the same line or not? You can imagine if this C is also on AB vector itself, then the area will become 0. So let's give an example of such a case. So I have a case -2, 3, 5. So 3 and 5, right? Now here I have 1, 2, 3. So 1, 2 and 3. And I have 7, 0, -1. So 7, 0, 7, 0, -1. Now the moment I press enter, you notice it has become a line. Why? Because A, B, C are on the same line. So they can't form a triangle. The area covered must be 0. So if you notice here 0, 0. Okay. So that is area, the area of a triangle, and the collinearity of 3 points. Treat them as a triangle, evaluate its area. If the area is 0, that means that it is not a triangle, it is a single straight line. That's it. Bye.